So hello guys, welcome back to my YouTube channel. So this is our second video on scaling our systems from 0 to 1 million user. Uh, this is the part which we had built in our previous lecture, where we had introduced one load balancer. Uh, what we had was a basic client server architecture, where this was our basic design which we had, and from this we had till now developed till here. It's the main components which are introduced in this part are the load balancers, the couple of servers which are mostly horizontally and vertically both scaled, which the concepts also which we had discussed in previous lecture, and the database as well, which we had scaled using master slave architecture, and we had some discuss concepts as well. So now looking into further scaling part, we had two more concepts to learn, which are cache and CDNs. So caches are mostly the temporary databases that are just like normal database, which are stored for uh, which are created for frequently used data, but the database is temporary, so it can reset, it can update, and just so many use cases, uh, having it as a much more faster than regular database operations. The most database operations are obviously hitting directly to the server and server giving back the response, but in cache it will be hitting to the server and giving it from the cache. Caches are mostly also of two types. We can have one which is in server, in memory, which is called as, and second type is it can have independent server. Independent are mostly Redis and OR, and in memories are we are using, let's say, hash map in the server. But one more disadvantage in hash map is using in memories. Once you restart the server, the value present in hash map will get lost and it gets reset to empty. So obviously most of the time we can use independent cache servers, so that it can give independent scaling functionalities and lot more use cases. So basically using cache, it can improve our performance of the server, and it decrease the load on the database. Having a separate cache DB, which I had discussed right now, is also useful for scaling it independently. One of the part is cache for Redis we can use, and most of the considerations which we can use while using cache are we should firstly decide when to use cache, because when the data is used frequently but modified infrequently, then only we can use cache. Because if the data is frequently updating, then we have to update the cache so too many times. So because of this we can the overhead will get generated, because once the data is getting updated in database as well and the cache as well, so it's kind of two times updation in the server which we have to bear. And one more time is obviously the data is in the cache in the database, but what about the cache data? Because it's a database, it can have a huge value, but the cache, we are storing the part which is mostly frequently used. And obviously if not all times the user will be going to use same data most frequently, so we have to change it within time to time and update the cache database. So for that we should have one expiration policy for the cache, so that let's say after 10 to 15 minutes of the cache server, is just basic guess, 10 to 15 minutes we can keep one expiration policy. Obviously it should not be that much of long that the data is still in the cache server and updation has been happened in database, but it's not updated in a cache. It can have a stale data, and again it should not be also that much of short, because it can create one more problem, that again updating in database and updating in cache will be going to overhead for our servers. it won't be that much of optimized approach to go forward with too long and too short part. We can have a bit more intermediate part. And one more part is we should do have consideration about consistency, as the database should be in sync with the cache. And sometimes modifying operations on data stores are also not in single transactions, so we should have to consider these all things. And obviously mitigating failures as well, where a single cache server can represent a potential single point of failure. So if the cache is getting failed, then we should route it to server. Otherwise our user experience won't be that much of good. And if you want to reduce dependency from cache, single point of failure, we can have multiple cache servers. But at that time as well, how we are going to manage multiple caches, and how whether we are putting the same data in multiple caches, or what kind of approach we are going to use, that's also a different part of story. So, and one more thing which we can see is eviction policy. uh, Obviously we have the data into the cache memory, but how are we playing with the data? Because not every time we are using it. So obviously we have to remove and we have to add up the data. And how we are going to do is, there are two types of algorithm: LRU, least recently used, and least frequently used caches. Whenever there are addition and deletion from the cache, we can also have one more lecture for these two algorithms to explain. uh, so this is it, this part of the topic which we had to introduce in our servers, which we'll be going to use it in at the end of this lecture for the cache. It was an overview for cache. Now the next topic is CDNs. CDNs are just simply basically similar to the cache servers. CDNs are, but only difference is that they store the static data, which are HTML files or JS or images and all. So these all static files are getting stored at CDNs. CDNs stand for Content Delivery Network. So what happens is, in real life scenario, CDNs are mostly, obviously these are similar to cache. That means they are the databases, small databases which are distributed in the whole world, where let's say some servers are near India, some servers are near USA. So whenever the user will be hitting to the website, uh, the website, obviously the request will be looking for the nearest CDN server which is located with, let's say the user is located in USA, then it will be looking for the nearest CDN server to have the static files, which will be going to reduce the latency for the user. At the if the data is that much of near to the user, then it will be going to have a nice user experience. Have so mostly let me show you how high level CDN works. Is when a user visits a website, a CDN server closest to the server will deliver the static file. So let's say user 1 is going to make a request to the CDN. So let's say CDN don't have the file, and then CDN will be looking for the file in server, and if the server will be giving up the response, and CDN will be storing those files into the server. Then CDN will be reverting back to the server user 1. And now let's say user 2 has also requested the same files. Rather than going back to the server, it will be going to return the response from CDN server only for all the static files which we had discussed earlier. So for those part only, the CDN server will be going to have a response which are stored, and if these are not stored, the CDN don't have it, then it will be going to request it to server, and it will be going to give a response. So basically most of the considerations also we have to do in CDN: when to use, when to not to use. CDNs are mostly third party vendors which are going to sell their services. So obviously we have to look into the cost part. Where are the your most of the users are located, and how are you are going to handle it. So with looking into the cost part, we have to take up the decisions. Setting up the cache expiry, so CDNs are also cache, so we have to set up the cache expiries as well. Obviously CDN fallbacks, if CDN is not working, we have to route back to the servers, and invalidating the CDN files. So how are we going to invalidate? We have the usually defined APIs which are provided by CDN vendors, and we can use them to invalidate those files. Invalidating caches, we had discussed two algorithms which are LRU and LFU. Similar way in CDNs, we are doing it with the help of CDN vendors APIs which are provided by them before let's say the time expiry, which are there for static files as well. So one more thing we can do is, let's say you have an update on your app, so you want to show one more updated image of your let's say on the website. So obviously the CDN don't know it, so we can do one more thing is that create versioning of the objects which will be sending in as an attribute only with the APIs, which is going to bifurcate all the versionings of the images stored into the CDN, and the old versions are going to delete anyways after the cache expiry. So these are all the considerations which we have to do. It's pretty much. So till now we have developed our website as developed our system as this much. We have DNS already, so user will be going to look up for the IP, and then we'll be going to look up for the CDNs, all the static files will be delivered to user, and then it will be going to hit for API requests with the load balancer balancing over the load. Not only one user, right, there are a lot many requests coming out there, and then the load balancer will be distributing those files into those requests into the servers as per the requirement, as per how servers how many servers are there, how each server is performing. So and then sending back the response from the database. And for frequently used data, we have cache server introduced right here. If we are asking for the frequently used data, cache will be going to return it from here only. So whenever request come to the server, it will be going to look up for the firstly in the cache whether it is present in the cache. If not, then it will be going back to this database and provide it to them. So this is pretty much architecture which we have currently developed.